Alright, so I'm here to do a projectile motion problem, and this is the second type of problem because if I look at my setup here, I'm fired up at some angle and it's going to follow a projectile across and it's going to come back to the ground. And I know that whatever velocity it leaves the ground at over here, it's going to come back to over here. So I'm going to trace out the path of this projectile. It's pretty simple. It just comes up, goes up, and comes back down. Perfect. Cool. So the question reads, if a projectile is shot at 10 meters per second, 45 degrees above the horizon, how far will it go? What is its hang time? And what is the maximum height that it'll reach? So how far, of course, is going to relate to the displacement of delta x. The hang time is going to be the total time it takes to go from this starting location here all the way across the projectile and back down. So the time that it takes to go up as well as the time that it takes to go back down. And finally, the maximum height is going to be reached right in the center here. So I'm going to put a little h here because that's going to be our maximum height. Okay, so the first thing I'm going to want to do in a problem like this is try to get as many of my variables defined as I can. So first off, I notice that I have a velocity here, and that velocity is 10 meters per second, but it's at 45 degrees above the horizon. This means that I'm going to have a velocity in both the x direction and the y direction. So I'm going to go ahead and get those broken down in components right now. So here's my velocity. It's 10 meters per second. But I have a velocity in the x direction as well as a velocity in the y direction. And my angle is right on the inside of this triangle. So using my trig identities, if I have Vx right here, well that's adjacent, so that's going to be cosine, and I have Vy right here, and that's going to be opposite, so that's going to be sine. So my Vx is going to equal V times the cosine of theta, and my Vy is going to equal V times the sine of theta. And if I plug in, first off, they're both 45 degrees, so they're actually sine of theta and cosine theta are actually both the same thing. It's going to be 0.707, or if you know your unit circle, you know that it's, what, root 2 over 2. So if I go ahead and plug in 10 times the sine of 45 or the cosine of 45, either one, doesn't matter, I'm going to get 7.1 meters per second. And that's going to be for both my velocity in the x direction as well as the velocity in the y direction. Alright, so I went ahead and I added these two velocities right there. Now notice that my velocity in the x direction is always going to be the velocity in the x direction. But for projectile motion, nothing changes that. There's no acceleration in the x direction. In the y direction, however, you'll notice that I put it's the initial velocity in the y direction. And the reason for that is we have non-uniform motion here because we're undergoing acceleration due to gravity. So it's going to start at 7.1 meters per second, but it's going to undergo an acceleration. Alright, so those are my initial starting conditions, and I could do other things such as put my y initial as being 0, as well as my xi being 0. So when my projectile starts, that means it starts at an initial height of yi of 0 meters. It starts at an initial x position of 0 meters. It's traveling in the x direction at 7 meters per second. And it starts at traveling in the positive y direction at 7.1 meters per second. Okay, so how far is my first problem? In the distance, or the displacement, it's uniform motion, so it's my easiest equation. My delta x equals velocity times the time. Now, the time that I'm looking at is going to be the total time in the air. It's the total time it takes to go across this entire projectile. In this type of problem, I'm going to split up that time. There's going to be a time that it takes to go up, and then there's going to be a time that it takes to go down. And the reason I'm doing that is because that'll also help me find the height in the middle. So the time that it takes to go up, well, it starts at 7.1 meters per second in the y direction. And the y direction always determines our time for a projectile. So the time that it takes to go up, if it starts at 7.1 meters per second, will be however long it takes to go from 7.1 meters per second to 0 meters per second. Because it's going to stop going up when yf at that instantaneous point is 0. So in this case, I have my initial velocity in the y direction equals 7.1 meters per second. My final velocity in the y direction equals 0 meters per second. And this is undergoing acceleration due to gravity, so A equals G equals negative 9.8 meters per second squared. So using that information, I know that I can use my most basic, or one of my most basics, equations to find the time. And that is going to be that VF equals VI plus AT. I'm solving for time. So I'm going to go ahead and, and my final velocity is 0, so I'm going to get rid of that. So I have negative VI over A equals T. And all I did was I got rid of the VF. I moved the VI over to the other side. That's why it became negative. And therefore, I then divided by A. So I have negative VI over A equals T. And then I can go ahead and plug into that equation. And I have negative 7.1 meters per second divided by negative 9.80 meters per second squared. And this is the time that it takes to go up. And all I do is plug in negative 7.1 divided by negative 9.8, and I get 0.72 seconds. So I'm going to put that equal to 0.72 seconds. So with that, I actually answered a couple things. First off, my time up, it's 0.72 seconds. So it takes me 0.72 seconds to go from the base all the way up to the maximum height. But in this type of projectile motion problem, we have symmetry. So if it takes me 0.72 seconds to go up, it'll take me 0.72 seconds to go down. So there's two things I figured out. The hang time, which is 0.72 seconds, times 2, which is going to be 1.44 seconds. And I can also use that to figure out how far it went, because the time for how far it went is going to be the hang time times the velocity in the x direction. So let me get caught up by plugging in a couple things and clearing off my workspace here. Alright, so you'll notice that I added my hang time over here, and I put my time up over here. So, to answer the first question of how far did it go, well, my velocity in the x direction, which never changes, is 7.1 meters per second. My time that it takes to go from the beginning all the way to the end is 1.44 seconds. So I have this equation right here that I'm going to go ahead and plug that in. So delta x equals my velocity in the x direction, which is 7.1 meters per second, times the time that it's in the air, which is 1.44 seconds. 1.44 seconds. All right. So I'm going to go to my calculator. I'm going to take 1.44 times 7.1, and I'm going to get, it's 10.224 meters. I'm going to call it 10.2 meters. I feel like that's going to be more than accurate given the amount of sig figs that I have. So this is my displacement. This is also how far the object traveled. Alright, and the last little step of this problem is figuring out what the maximum height is. Now the maximum height is reached when the y final velocity is 0 meters per second. Okay, so what I need to figure out is how high it is right here. So if my velocity final in the y direction is 0 meters per second, what I'm actually looking for is the displacement in the y direction. So I have a couple things, and I made this change. I kind of goofed that up. That should have been velocity final in the y direction, so sorry. But my initial velocity, or my initial position, which is 0 meters, I'm looking for my final position, which is still at that same point. So that's yi and yf. I have vi in the y direction. I have my t, and I have my a. So I have a couple options that I can do for this. I think the easier one of the two is vf squared equals vi squared plus 2g delta y, or 2a delta x if you prefer. Just because I already had everything for that equation. I could also use the YF equals YI plus VIT plus 1/2 GT squared. It would get me the same answer, but there's going to be some round-off error just because of my time, but I would still use only the 0.72 seconds for that because it only takes the half of my hang time to go up. So anyway, though, my final velocity is going to be 0. I'm looking for delta y, so I have negative VI squared over 2G. So that equals negative, well, my VI is going to be 7.1 meters per second, and that quantity is going to be squared, divided by 2 times my gravity, which is negative 9.80 meters per second, squared. And then I can go ahead and plug that in, so 7.1 squared, divided by 2 times 9.8. The negatives, of course, cancel out, and I get a maximum height, or a delta y, equals 2.57. So we'll say 2.6 meters. So the maximum height that it's going to reach is 2.6 meters. So with that, all my questions have been answered. How far does it go? Well, it goes 10.2 meters. What's its total time in the air? Well, that's 1.44 seconds. That's a combination of T up plus T down, which we didn't have to do because we just doubled T up. And the maximum height that it reaches vertically is going to be 2.6 meters. So that is the basic type. The second type of problem was solving projectile motion.